and this one is very sparse, but they're clearly kind of two clusters going on here. And you think of these as coming from two distributions of the data. All of these points have similar distances to their nearest neighbor as their nearest neighbor has distances to each other, and the same here. So if you just looked at some density-based region where you kind of looked at the density, this is much less dense than this one is. But these are not outliers. These just represent a kind of a more sparse distribution. So this is a little bit more effective, but you still need some notion of some threshold of what is the ratio of these two distances, and at what point do you decide to exclude some of these data points. So this is kind of a neat, kind of a slightly more effective way of using this reverse nearest neighbor, but it's a bit more computationally intensive. Okay, so just a couple minutes left. There's one more kind of, so I guess I won't get to the other two topics. Maybe if the privacy lecture ends a bit earlier, I'll get back to them a bit, which will be on Monday. But I just want to mention some other kind of newish issue that's come up in large data sets, and this is the idea of having a heavy-tailed distribution. Right, so like a Gaussian distribution is not heavy-tailed. It kind of drops exponentially fast as I get further out, the probability of getting data points out. So, but a heavy-tailed distribution is kind of like the idea of like, one way to explain this is thinking of books and how Amazon was able to kind of take over the entire book industry. So if you're in a bookstore, a bookstore can carry maybe 10,000 books, 10,000 distinct books. And so it turns out what people's interests, they would, you know, most of these, they like these 10,000 books, but, you know, maybe 2/3 of the time they want one of these 10,000 books. But 1/3 of the time they want a book outside these 10,000. And so Amazon said, well, we can have a warehouse and have like 1 million different books. And we can offer customers these 1 million different books. And this is 1/3 of the entire market of books that people wanted were outside the books you could carry inside of a bookstore. This is a much kind of broader interest, and maybe each of these books in this between the 10,000 most popular and the 1 million most popular, maybe they'd only sell like 1,000 books over the course of the company, but that's still enough that they can do these economies of scale, and they don't need to sell that many books, right? And then so this is how Amazon was like 10 years ago. Now, you know, they don't even need to have these in stock. They still probably keep maybe 1 million. Maybe they keep a little bit less now in stock. Now, the other books, there are two new options. One is they're now option to actually print a book on demand. They don't need to keep it in their inventory. If you order it, they actually can print the book then, and then send it off to you. Or you can just buy it and download on your Kindle. That costs them almost nothing to store. They need to keep the PDF on a server someplace. That's incredibly cheap. But now they can offer basically any book available that they strike a deal with the owner of it with, they can sell you that book on your Kindle. So this is a very heavy tail. There's an incredible number of different sorts of books people want to buy. And Amazon was really one of the first companies to figure out how to capitalize on this. So another company which capitalizes on this is like Google. The search results, people, and we'll talk more about how search engines work in the PageRank section of the class. But you know, the top, there's kind of maybe 1,000 or maybe 10,000 really popular searches that make up maybe 2/3 of all searches. But then there's a large number of these other searches that people want to know about, and it's hard to get good results on these. And so Google had found a way to kind of understand these new keywords. Maybe no one has ever searched, you know, for these keywords before. They can generate some data on them. So there used to be a game called, I forget what it was called, like Google Wapping or something like that, where you try to search for a word in Google where there was only one web page for that word. Now, anything you search, they're going to return something and probably a bunch of ads too, right? Even though no one's ever searched for that before. But they had this ability to index the stuff that other search engines weren't indexing. They may say there were actually no results for this keyword, right? So by having this larger set of keywords, they were able to attract more and more of an audience. And so when you have these heavy tail distributions, the idea of finding outliers and trying to remove them is kind of the wrong way to go. You want to somehow figure out how to efficiently and effectively model and handle these things that happen very infrequently. You don't want to throw away these outliers. You want to somehow deal with them. And there's new economies growing all the time because of this. People are figuring out how to deal with this heavy tail. And so in small data sets, you rarely never see it, or if you do, you think that the part of the heavy tail is actually an outlier. But in newer, larger data sets we're seeing, these heavy tail distributions exist a lot of the time. Not all the time, but enough that, really think twice before you try to filter out your outliers in your data set. Okay, so I'll see you on Monday.